Good morning, my YouTube viewers. Crystal here. I'm going to do a short-ish video for you today because my alarm is going to go off in 15 minutes or 14 minutes really, and then I have to get up and go to my day job. What I wanted to do was I wanted to make a video for you about this water competition question that I did on the DrivenData website. The DrivenData website said that this competition question is for fun, and if you share it on their Twitter account, or I think share it on their discussion, but I share it on my GitHub account. So it's freely available on my GitHub account, so you can call up on my GitHub account. It says water IPYNB, and you can get it and follow with me. The problem statement to this competition question on the data, it's the question about the water pumps. It says using data from the water, can you predict which pumps are functional, need some repairs, and which don't work at all? Predict one of these three cases on a number of variables and what kind of pump is operating when it was installed and how it is managed. A smart understanding of which water points will fail can improve maintenance, ensure clean, potable water is available to communicate across Tanzania. So the first was I imported some of the libraries that I would need, such as Pandas, NumPy, Matplotlib, and Seaborn. The thing I did was imported files, and the files are really big, so I'm not able to put them on my GitHub account. So you can download them from the Data Driven website on their competitions page, and it's about the water pumps. You're looking at the train file, and it gives you all of this information on the train file, and you notice that you have a lot of information that is what shall we say, text-based. And since this information is text-based, it's going to have to be converted to numerical order before the computer can do anything with it, because the computer can't do anything with text. Then we downloaded our labels file, so they did not include the labels with the train file. So what we're going to have to do is, before we do anything else, we're going to have to merge the data, and I'll show you how to do that. Then we downloaded our test file, and then we downloaded a sample, which is what Data Driven wants to see when you input your answer. So we merged our train file. So train equals train.merge, labels on ID to the right. So you can see on the very right, you've got status group, which is what was on the labels file. We check to see if we have any null characters in the train file and the test file, and there are loads of null characters. So what I decided to do was I imputed the variables, but in one, just in one column, I replaced all of the replaced all of the missing values with mode, and the mode is the most commonly occurring value. They also have a command called simple imputer or imputer in sklearn, and I'm going to try to learn how to do that, but I just did this for the time being. Then we checked to see if there were any null characters. No, there were not any null characters after we imputed those null values. So what I wanted to do was I wanted to convert the date recorded to a number, and then I wanted to use only the year, because I decided, well, it's not going to make that big of a difference if you do like the month and the day that it was recorded. I thought, well, it's going to be more meaningful if you just record the year that it was recorded. So train date recorded equals train date recorded, string replace dash with space, train date recorded equals train date recorded, string, and I only wanted the years. Train date recorded equals train date recorded as type int, so I made it an int. So I did exactly the same thing with the test file as well, because I just thought, well, it's going to clutter up. I mean, this computer has a lot of information to go through, and it's just going to clutter it up if you have the month and the year that it was recorded. And I just thought, well, it's not going to take away from the meaningfulness of the information if I just use the year. And there's another column in the data where it said they wanted to know what year the pump was built. And so if you're using the year that the pump was built, I thought, well, it's going to be okay to use the day that the information was recorded. We did a plot on this, and you notice we have to use new plots because I'd previously been using distplot, and distplot has become deprecated, and so now you have to use either histplot or distplot. So I decided to use distplot. So you can see functional. Most of the wells are functional, and then about the middle of them are non-functional, and then a small amount are functional that need repair. So what we did was we counted all of the ones that were functional, non-functional, and functional that need repair. And what we wanted to do was we wanted to check the percentages to see the percentages of the functional, non-functional, and functional but needs repair. So you can see that it was 7%, 7.7% were functional but needs to be repaired. So we do have a class imbalance here. I think most of the problems that I've worked on have been a class imbalance. So what we did was we used the label encoder to encode the label, and the sklearn documentation says that the label encoder is only supposed to be used on the label and nothing else. And I know in previous videos I'd been using the label encoder for other work, but I thought, well, I'll try a different tactic this time. And so this time I just used the label encoder to encode the label, so I converted everything to 0, 1, and 2. We used a distplot again, so we wanted to see the status group again. And we did that after we had encoded the labels. So you see most of the values are 0, 2, and then 1. And now what we did was I tried out the ordinal encoder, and the reason why I used the ordinal encoder is because the sklearn documentation says you're not supposed to use the label encoder for anything other than the label. Here I use the ordinal encoder, but you see that I had to manipulate the columns before I could do it. So for example, train funder equals inc fit transform train funder values reshape -1 1. So I had to actually reshape the column because the column was a one-dimensional array and they wanted it a little bit different from what it was. So we had to use the values. You couldn't just reshape the column. You had to do train funder values, reshape -1 1. So, but after we reshaped the column, we were able to use the ordinal encoder. And the ordinal encoder is what you're supposed to be using for the X values. I did this for the train, and then I also did it. And as you'll see that I had a lot of columns that I needed to reshape. So now you can see the train file. It's all numbers, which is what the computer wants to see. and the test file is all numbers as well, which is what the computer wants to see. So then I've got a heat map, and so you can, if you're good at reading heat maps, you can see how all of the different variables interrelate with each other. This heat map here, when it said extraction type class, that seems to be, important. But yes, if you're good at reading maps, you can always read the heat map and see how the different variables relate. Now what we did is we defined our X, Y, and X test. So Y is train status group, X is train drop ID, status group, axis equals 1, X test equals test drop ID, axis equals 1. And now we set our train set up for train validation. So X train X val, Y train Y val equals train test split, X, Y equals 0, test size equals 10, satisfy equals yes, shuffle equals 2. You have to set satisfy equals yes because we have a class imbalance, and they do a stratified fold on it, and they try to make, if you say stratify equals yes, then what happens is they try to give you an equal distribution of the training file, of the validation file, as you have on the training file. And then shuffle is also to do with shuffling it to make sure that you have an equal distribution of examples on the validation file that you have on the training file. So now we put the information on the scalar, and the thing to know about scalar is you're only supposed to fit it on X train, and you transform it on X train, X val, and X test, which is something that I had to learn, and that was one of the reasons why I never could get the scalar to work properly, because I was fitting it on everything, and you're not supposed to fit it on everything. You only fit it on X train and nothing else. So now we set our class weights. Since there's a class imbalance, you can see our class weights have been set. And then now what we do is we do another plot of what X val or Y val looks like, because we're going to be testing on X val, and Y val is going to be our validation. We put Y val on a counter, and you can see how many values you have of each class. And again, you can see that we have a class imbalance. And then we put Y val on the percentages, and you can see the percentages of Y val. And so now what I've done is I have selected a group of models that I wanted to test out, and I did this. The model that I selected was AdaBoostingClassifier, but I tested it on XGBoost, Hist Gradient Boosting Classifier, Heat Classifier, and what I decided to do was after I conducted all of my tests, because that's what data science is all about, testing, I decided to use the AdaBoost classifier as the most efficient model to use, even though I tested on all of the other classifiers. So we predicted on our X val. We used the accuracy score because that's supposed to be similar to the score that was used with the DrivenData website. We put YPRED on a counter to see how many values we had of 0, 1, and 2. We put YPRED on percentages, but that's not very meaningful in this particular exercise because we had a 0, 1, and 2, and so we don't know exactly what percentages we had of 0, 1, or 2, but I left it in there anyway. We created a confusion matrix so you can see what examples we had of 0, 1, and 2, if you're really good at confusion matrices and you wanted to do that. And we did a disk plot of YPRED so you could see the distribution of 0, 1, and 2. Now what we did was predicted on the X test. We did an X plot on the X test, and you'll see that there wasn't a very good distribution of ones, that there was definitely a class imbalance in the ones. We did a prediction on the percentage, but that's not very meaningful, but I left it in there anyway. Now what we have to do is we have to reverse our label encoding. And then we have to prepare our submission. And then after we have prepared our submission, we convert it to a CSV file. And then we load it up into the DrivenData file. And I can tell you for the ADA booster, I got a 0.8060 for the ADA boost classifier. And on the 0.8060 was pretty high, because if I go into the leaderboard, which I know you can't see yet, but I'm just trying to get into the leaderboard now. If I go into the leaderboard, the highest one was 0.8294. So I was like less than 3 points lower than the highest value by using the ADA boost classifier, using label encoder, ordinal encoder, and testing the models. I tested on, I think, 5 different models, but I could only select the 3 models that had the highest accuracy, because with DrivenData, you're only allowed to submit 3 submissions in a day. So I think my score was only 3 points less than the highest score. So I needed that. So you're welcome to my GitHub account file and follow along with me. If you like my video, please like, subscribe, and share. If you like the work I do and want to make a donation, I've got my email address to my GitHub account in the section down below. I don't have enough subscribers to get monetized, so I have donations if I want to make money on this channel. And thank you so much